stupid satellite imagery and they realize, oh my God, that's the caldera of a volcano, like this Yellowstone thing. We thought it was just this crazy place with hot springs. Like, no, that's a supervolcano that is a continent killer.
Joe Rogan has recently revealed that beneath the beauty of Yellowstone National Park lurks a sleeping giant, waking up from its sleep. Scientists have recently sounded the alarm as well that the massive dome-shaped uplift within the park is growing at an unprecedented rate. What does this mean for us? And could this signal a catastrophic awakening? Join us as we dive into the mysteries of Yellowstone's supervolcano. Understanding Yellowstone's volcanic nature. Yellowstone National Park, celebrated for its stunning natural beauty, is also the site of one of the world's most colossal geological features, the Yellowstone supervolcano. This supervolcano underlies a significant portion of the park, presenting a fascinating but daunting aspect of the region's natural heritage. In the same site, a massive dome-shaped uplift was discovered by scientists. While it was being observed, there was no indication what its purpose was. But recently, a shocking announcement made by Joe Rogan terrified the whole world. Why did the Yellowstone System Alert announce that this dome is increasing in size, and why is it such a cause for concern for scientists? The geological history of Yellowstone is marked by 3 immense volcanic eruptions that have significantly shaped the landscape and impacted the environment far beyond the park itself. The supervolcano's formation began with the Huckleberry Ridge eruption approximately 2.1 million years ago. This massive eruption created the Island Park caldera and expelled such a vast quantity of ash that it covered much of the current United States. The volume of material ejected during the Huckleberry Ridge eruption is estimated to be around 2,500 cubic kilometers, making it one of the largest eruptions known to have occurred on Earth. The ash from this eruption can still be found as far south as Louisiana and as far east as the Mississippi River, indicating the vast reach of its impact. The second major eruption, known as the Mesa Falls eruption, about 1.3 million years ago, was similarly powerful, forming the Henry's Fork caldera and depositing extensive ash layers across the continent. This eruption produced approximately 280 cubic kilometers of volcanic deposits, blanketing the surrounding landscape and significantly altering the geological framework of the region. The aftermath of the Mesa Falls eruption saw significant changes in the local flora and fauna as the landscape was transformed by the deposition of volcanic materials. The most recent major eruption occurred about 640,000 years ago, the Lava Creek eruption. This event formed the modern Yellowstone caldera and ejected an enormous volume of material, with ash reaching as far as the Gulf of Mexico. The Lava Creek eruption is notable for its size, with about 1,000 cubic kilometers of material ejected, and also for its dramatic effects on the climate. The ash and gases released into the atmosphere likely caused a volcanic winter, significantly lowering temperatures globally and impacting life far beyond the immediate vicinity of Yellowstone. These eruptions are significant for their massive effects on global climates and ecosystems, demonstrating the supervolcano's capacity for widespread environmental impact. The scale of these eruptions and the frequency with which they occur make the Yellowstone supervolcano a subject of intense study and monitoring in the geologic community. The potential for future eruptions, while statistically rare, poses a serious risk due to the supervolcano's history of producing massive, climate-altering events. Such historical data help scientists predict potential future activity and develop plans to mitigate the effects of any such events. In more recent times, signs of ongoing volcanic activity have been observed, raising concerns about the potential for future eruptions. Among the most notable indicators is the rising of the ground in certain areas of the park, particularly noticeable as a dome-shaped uplift. This phenomenon suggests that magma is accumulating beneath the surface, exerting pressure that deforms the overlaying earth. This swelling is a clear sign of magmatic activity and could potentially precede further volcanic events. This type of ground deformation is meticulously monitored using GPS and interferometric synthetic aperture radar technologies, which provide precise measurements of even slight changes in the Earth's topography. Continued observations have shown that these uplift events can vary in intensity, but often correlate with increases in seismic activity, which further suggests a recharging of the magma chamber beneath the caldera. The combination of surface deformation measurements and underwater monitoring tools offers a comprehensive view of the geological activity beneath Yellowstone. These signs are integral to the ongoing research and monitoring efforts aimed at predicting future volcanic events and understanding the complex interplay of forces driving the Yellowstone volcanic system. Such detailed and continuous monitoring is crucial not only for scientific understanding, but also for effective disaster preparedness and management, ensuring the safety of millions who visit or live near this iconic park. Experts in geology and volcanology are closely monitoring these developments. The increasing size of the dome-shaped uplift and the shifting water levels in Yellowstone Lake are critical data points for scientists, providing insights into the behavior of the underground magma chambers. Although these signs do not necessarily indicate an imminent eruption, they are crucial for understanding the supervolcano's current state and potential future activity. The implications of these observations are significant. Should Yellowstone's supervolcano erupt again, the consequences would be catastrophic, not just locally, but globally. The eruption would likely eject massive quantities of ash and gases into the atmosphere, potentially triggering a volcanic winter with dire effects on global agriculture and climate. Thus, the ongoing study and monitoring of Yellowstone's supervolcano are vital for preparing for potential future events. Researchers utilize a variety of tools, including seismographs, GPS systems, and satellite imagery, to monitor the park's geological activity. These instruments help scientists track even slight changes in the Earth's movement and magnetic fields, providing early warning signs of increased volcanic activity. While the beauty of Yellowstone National Park attracts millions of visitors each year, the underlying supervolcano reminds us of the powerful natural forces at work. Understanding these forces is a matter of scientific interest and of global importance, as the potential impact of an eruption could affect the entire planet. The continuous monitoring and research conducted by geologists and volcanologists are essential to safeguarding the future, providing crucial data that helps predict and mitigate the effects of these formidable natural events. The impact of Yellowstone's eruptions on global climate. Yellowstone National Park also sits atop a supervolcano with the power to affect global climates. The history of Yellowstone's eruptions gives us valuable insights into the potential consequences of future volcanic activity, particularly concerning the impact on the Earth's climate and ecosystems. Yellowstone's supervolcano has erupted 3 major times in the past, with each event leaving a significant mark on the Earth's environment. The most recent of these, the Lava Creek eruption approximately 640,000 years ago, ejected a massive volume of ash and gases into the atmosphere, covering much of North America. Such large-scale eruptions have the potential to alter global weather patterns. For instance, volcanic ash and sulfur compounds can block sunlight, reducing temperatures and disrupting weather systems. This effect has historically led to colder temperatures across the globe, affecting agricultural productivity and biodiversity. In the case of Yellowstone, the ash from these eruptions can be found as far away as the Gulf of Mexico, illustrating their wide-reaching impact. If Yellowstone were to erupt today, the effects could mirror those of its past eruptions, but on a potentially larger scale due to the denser human population and more interconnected global systems. A future eruption could expel thousands of cubic kilometers of ash and gases into the atmosphere, leading to substantial environmental changes. The ash would likely devastate local ecosystems, burying landscapes under a thick layer of debris. This could destroy crops, contaminate water supplies, and lead to the loss of animal habitats, causing significant biodiversity upheaval. The heavy ashfall could also disrupt air travel significantly, as the fine ash particles can damage aircraft engines, leading to widespread cancellations and rerouting of flights. This disruption could have a ripple effect on global commerce, particularly for industries dependent on just-in-time delivery systems. The health implications for populations exposed to fine volcanic ash include respiratory problems, eye damage, and skin irritation. Public health systems could become overwhelmed, dealing with the increase in respiratory ailments and other health issues related to ash exposure. Urban areas near the eruption would face enormous cleanup costs and potential structural damage from the weight of the ash accumulation. The concept of a volcanic winter arises from the significant reduction in temperature caused by volcanic ash and sulfuric gases in the atmosphere, which block sunlight. Following a massive eruption like those in Yellowstone's history, these materials could remain in the atmosphere for years, reflecting solar radiation away from Earth and cooling the planet's surface. This phenomenon could lead to a decrease in global temperatures, shortened growing seasons, and reduced agricultural yields, potentially causing global food shortages and famine. The extent and duration of a volcanic winter would depend on the size of the eruption and the volume of materials ejected into the atmosphere. The cooling of the Earth's surface would affect food production and alter precipitation patterns, potentially leading to increased flooding or severe droughts in different parts of the world. The disruption to the climate system might also affect ocean currents, which play a critical role in regulating weather patterns and climate worldwide. A Yellowstone eruption could thus have catastrophic effects locally and also globally, affecting climates, ecosystems, and human societies across the world. It shows the importance of monitoring the supervolcano's activity and researching its patterns to better predict and prepare for any future eruptions. Such preparations are crucial for mitigating the potential impacts on global agriculture, biodiversity, and human health, ensuring that societies worldwide can respond effectively to such a significant geological event. Early warning systems and international cooperation will be key in managing the response to such an eruption, helping to evacuate people from the most dangerous areas and coordinating global efforts to address the environmental and economic challenges that would follow. Understanding the full scope of Yellowstone's impact on global climate through past records and theoretical models helps scientists and policymakers develop strategies to protect ecosystems and human communities from these massive natural disturbances. Other secrets of Yellowstone National Park, while renowned for its stunning landscapes and geothermal wonders, is also a place of mystery and intrigue. Beyond the scientific understanding of its supervolcano, there are numerous unexplained phenomena, conspiracy theories, and unsolved disappearances that add a layer of mystery to this majestic park. One such unexplained phenomenon is the park's frequent seismic activity, which far exceeds that of any other volcanic region in the world. Although most of these tremors are small and cause no immediate concern, their sheer number and the patterns they sometimes exhibit can perplex even the most experienced geologists. For instance, the swarm events, where hundreds of small earthquakes occur over a short period, can sometimes suggest magma movement beneath the surface, yet often no clear evidence of such movement is found. Furthermore, some of the park's thermal features exhibit behaviors that are not entirely understood. Geysers like Steamboat, the world's tallest active geyser, have unpredictable eruption schedules that can suddenly change from dormant periods of several years to active phases with frequent and spectacular eruptions. These erratic patterns pose challenges to the understanding of hydrothermal dynamics and raise questions about the interconnectedness of the park's underground systems. Yellowstone has not escaped the attention of conspiracy theorists. One of the most pervasive theories is that the park's supervolcano is a potential doomsday device, with rumors suggesting that government agencies have contingency plans to evacuate the entire North American continent in case of an eruption. While these theories have no basis in documented fact, they capture the imagination of many who are fascinated by the park's powerful and potentially destructive natural forces. Another popular legend involves the so-called Zone of Death, a legal gray area in the park that theorists claim could be exploited to commit crimes without consequences due to a loophole in the Constitution. Although this is more a curiosity of legal theory than a practical concern, it adds to the mystique and eerie allure of the park. Over the years, Yellowstone has been the site of several mysterious disappearances that remain unsolved. Due to its vast and rugged terrain, it is not uncommon for visitors to go missing. However, some of these cases have peculiar aspects that make them particularly baffling. For example, some disappeared individuals were experienced hikers and outdoorsmen familiar with the terrain, yet they vanished without a trace, leaving behind few if any clues. Search and rescue efforts in these cases often find themselves at a loss, with no explanation for the person's disappearance. The park's dense forests and remote areas also contribute to the difficulty of search operations, worsening the mystery when someone goes missing. These unsolved cases continue to perplex and intrigue both authorities and the public, adding an element of danger to the natural beauty of the park. The presence of strange sounds and lights reported by visitors and rangers alike further deepens the park's enigmatic reputation. Some reports describe unexplained noises that do not match any known wildlife or natural phenomena, while others recount sightings of unusual light formations in the sky, neither of which have been satisfactorily explained by park officials or scientific investigations. The combination of unexplained natural phenomena, intriguing conspiracy theories, and mysterious disappearances make Yellowstone a place of endless fascination. These mysteries invite both caution and curiosity, reminding visitors that for all its beauty, Yellowstone holds many secrets that are yet to be uncovered. As we continue to explore and study this remarkable natural wonder, we may gradually peel back the layers of mystery, but it's likely that some secrets of Yellowstone will remain elusive, captivating the imaginations of visitors and researchers for generations to come. Yellowstone's geological secrets. Yellowstone National Park is also a geological wonderland. The park lies atop one of the most intriguing and studied supervolcanoes in the world. Beneath the beauty of Yellowstone's rolling landscapes and vibrant geysers lies a sleeping giant, the Yellowstone caldera, a supervolcano with the power to alter global climates. This caldera was formed by a series of massive eruptions, the most recent of which occurred approximately 640,000 years ago. These eruptions have left behind a landscape rich in geological features, including vast lava flows and ash deposits that stretch across the park. The extensive lava flows are remnants of the explosive events that shaped this region, with some flows still visible as dramatic basalt formations, showcasing the molten rock that once flowed freely across the park. These past events have created geological features that tell the story of Earth's dynamic interior processes. The caldera itself is not a singular visible feature, but rather a region of geothermal activity that spans almost 3,500 square miles. It's marked by a combination of high volcanic gas emissions, earthquakes, and ground uplifts and subsidence. These are dynamic processes that hint at the ongoing movement of magma beneath the surface. This continuous activity makes Yellowstone a natural laboratory for studying volcanic and geothermal processes. One of Yellowstone's most famous features is its complex hydrothermal system, which is among the largest in the world. This system powers the park's famous geysers, hot springs, fumaroles, and mud pots. Old Faithful, the park's most iconic geyser, is just one of more than 500 geysers in the park, making up 2/3 of the world's geysers found in Yellowstone. These hydrothermal features are fueled by heat from the still active magma chamber below the caldera. Water seeps down to as deep as a mile underground before being heated by this magma. The superheated water then rises back to the surface, erupting in geysers or forming colorful, steaming hot springs and bubbling mud pots. The vibrant colors often seen in and around these thermal features are due to thermophilic bacteria, which thrive in the extreme temperatures of the waters. Yellowstone's unique ecosystem is also a direct result of its volcanic history. The nutrient-rich soil from decomposed volcanic rock supports a diverse range of plant species, which in turn supports a variety of wildlife, from elk and bison to wolves and bears. This interplay between geology and biology provides an excellent example of how Earth's physical processes can drive biological diversity. Yellowstone is also one of the most seismically active areas in the United States, experiencing anywhere from 700 to 3,000 earthquakes annually. Most of these are minor, but the constant seismic activity is a reminder of the dynamic forces at play beneath the park. Earthquake swarms, which are sequences of earthquakes striking in a specific area over a short period, are particularly common in Yellowstone and are a subject of close monitoring and study. They are often centered around the massive magma chamber that influences much of Yellowstone's geothermal activity. Additionally, the ground in Yellowstone is perpetually rising and falling due to the pressures exerted by the underlying magma. This ground deformation is tracked using GPS and satellite data, helping scientists understand the subsurface movements and predict potential volcanic activity. Beyond its beauty and as a natural feature, Yellowstone's geological structure poses significant risks. The supervolcano's potential to erupt again is a source of concern, though such an event is statistically unlikely in any given year. However, the ongoing research and monitoring efforts are crucial in predicting possible eruptions, which could have profound implications for the global environment. Yellowstone's geology continues to be a subject of fascination for its potential danger, and also for the incredible insights it offers into the Earth's volcanic processes. As scientists unravel more of Yellowstone's secrets, they provide a deeper understanding of how our planet functions and evolves. Tying together global volcanic activity. Volcanic activity is not isolated to Yellowstone. It is a global phenomenon, with supervolcanoes and significant volcanic sites spread across the Earth. Understanding these global geological structures helps us appreciate the interconnected nature of the Earth's crust and the advanced technologies that allow us to monitor these potentially cataclysmic systems. Beyond Yellowstone, the Earth is home to several other supervolcanoes, each with the power to cause significant alterations to the global climate and environment. The Toba caldera in Indonesia and the Taupo volcano in New Zealand are two such examples. The eruption of Toba around 74,000 years ago is one of the largest known volcanic events in the last 25 million years. It is believed to have had huge effects on the global climate, possibly triggering a volcanic winter that drastically affected life on Earth at that time. This event is thought to have created a genetic bottleneck in human populations due to the severe environmental changes it caused, which dramatically reduced human populations in some areas. Additionally, the ash from the Toba eruption covered vast areas of South Asia with a thick layer, significantly impacting the ecosystems and leading to the extinction of several species. The Toba catastrophe theory suggests that this eruption caused a global volcanic winter, reducing the global temperature by 3 to 5 degrees Celsius, and it took the planet thousands of years to recover from this climatic change. Similarly, Taupo, though smaller than Yellowstone and Toba, has had a history of very large explosive eruptions, the most recent of which occurred about 1,800 years ago and is known for its widespread ash fallout. This eruption, known as the Hatape eruption, is believed to have ejected more than 100 cubic kilometers of material, making it one of the most violent eruptions in the last 5,000 years. The impact of this eruption was felt across much of the central North Island of New Zealand, with ash deposits still visible today. It caused significant environmental disruption and affected the local Maori population, whose oral histories describe the skies darkening and the sun being obscured for days. These supervolcanic eruptions highlight the interconnected nature of geological activity and the potential for regional events to have global consequences. Such historical data are crucial for modern scientists as they study supervolcanic activity and attempt to predict future eruptions. Understanding the impacts of past eruptions helps in preparing for possible future events, ensuring that global communities can better withstand and recover from such profound environmental disturbances. Moreover, supervolcanic activity extends beyond these well-known sites to lesser-known but equally potent volcanic systems like the Era caldera in Japan, known for its large caldera-forming eruption 22,000 years ago, and the Long Valley caldera in California, which experienced a significant eruption about 760,000 years ago. These supervolcanoes hold massive magma chambers beneath them, which, if activated, could release volumes of ash and gases capable of altering weather patterns and impacting global agriculture. The Era caldera, located in the Kagoshima prefecture, is particularly notable for its historic eruption and for its current activity, which includes regular ash emissions and seismic activity from the Sakurajima volcano, a post-caldera cone within the Era system. This ongoing activity highlights the caldera's potential threat, especially considering its proximity to densely populated areas. Similarly, the Long Valley caldera presents significant risks with its frequent earthquake swarms and ground deformation, indicating ongoing magmatic processes. The region around Long Valley has been subject to intensive geological study to better understand the risks associated with its potential for future volcanic activity, which could have devastating local and regional effects. The Earth's volcanic activity is linked through a complex web of tectonic interactions. Most of the world's volcanoes are located along tectonic plate boundaries, such as the Ring of Fire in the Pacific Ocean, where oceanic plates meet continental plates, leading to frequent and sometimes very explosive volcanic eruptions. These geological activities are not isolated. An eruption in one part of the world can influence volcanic and seismic activity elsewhere due to the interconnected nature of the Earth's tectonic plates. This interconnectedness was notably observed when the 1991 eruption of Mount Pinatubo in the Philippines influenced geothermal activity in geysers and hot springs in Yellowstone, over 8,000 miles away, due to shifts in the Earth's crust and atmospheric conditions. Such phenomena show the global scale of volcanic impacts, highlighting the importance of international monitoring networks. For instance, pressure release from one volcanic eruption can lead to changes in magma pressure in connected magma chambers, potentially triggering eruptions in different locations. This global network of volcanic activity is closely monitored by geologists and volcanologists to understand patterns and predict future eruptions. This monitoring is supported by global collaboration among volcanic observatories, sharing data and insights that help refine models of volcanic behavior and improve predictive capabilities. The advanced technology used in this field, from satellite imaging to deep Earth sensing equipment, plays a crucial role in forecasting eruptions and mitigating their potential damage, thereby safeguarding populations and economies that could be affected by these colossal natural events. The monitoring of volcanoes has dramatically improved with the advent of modern technology. These tools allow scientists to measure ground deformation, detect earthquakes, and observe changes in the landscape that precede volcanic eruptions. GPS technology, for instance, can detect even minute movements in the Earth's crust, providing early warnings of possible volcanic activity. Seismic monitoring networks around the globe continuously record the Earth's movements, sending data in real time to monitoring centers that analyze this information to forecast potential eruptions. Satellite technology provides a bird's-eye view of volcanic sites, offering visual evidence of changes such as increased gas emissions or thermal anomalies on the Earth's surface. In addition to these monitoring tools, thermal cameras and gas analyzers are deployed at many volcanic sites to track the release of volcanic gases like sulfur dioxide, which can indicate rising magma. These measurements are often combined with ground-based observations and historical data to assess the likelihood of an eruption. These technologies help in early detection and in ongoing research to better understand the behaviors and triggers of volcanic eruptions. The data collected is invaluable in developing models to simulate potential volcanic activity, which in turn aids in planning and preparedness efforts worldwide. Through the interconnectedness of tectonic activities and the application of advanced technologies, scientists are better equipped than ever to monitor these powerful natural phenomena, enhancing our ability to predict and mitigate the effects of volcanic eruptions on a global scale. Preparing for potential disasters. As the presence of the Yellowstone supervolcano remains a pivotal concern for geologists and public safety officials alike, understanding the processes of monitoring and preparing for potential volcanic eruptions is essential. Monitoring efforts, spearheaded by the Yellowstone Volcano Observatory under the United States Geological Survey, involve a comprehensive network of seismographs, GPS stations, and gas sensors strategically placed throughout Yellowstone National Park. These tools continuously assess earthquake activity, ground deformation, and gas emissions, all critical indicators of changes in volcanic activity. The monitoring infrastructure is designed to detect early signs of magma movement that could precede an eruption. Seismic activity is particularly telling, as earthquakes can indicate shifting magma beneath the surface. GPS measurements offer precise data on ground movement, a symptom of pressure changes within the magma chambers. Additionally, analyzing gases emitted from the park's numerous geothermal features provides clues about the magma's depth and movement. In terms of emergency preparedness, the National Park Service, together with the USGS and state emergency services, has developed detailed response strategies to address potential volcanic events. These plans include predefined evacuation routes, public communication protocols to disseminate timely and accurate information, and collaboration with local emergency responders to ensure readiness. Communities surrounding Yellowstone are regularly involved in drills and informational meetings to heighten awareness and preparedness for a volcanic crisis, emphasizing the practical steps residents and visitors should take in the event of an eruption. Public education plays a crucial role in disaster preparedness, with ongoing efforts to inform and equip park visitors and local populations with the knowledge and tools to respond effectively to volcanic threats. Information on how to prepare for and react to an eruption is made available through various media, including online platforms, brochures at visitor centers, and community workshops. Essential advice typically covers keeping emergency supplies, understanding evacuation procedures, and staying informed through official channels for updates on volcanic activity. Ensuring that the public remains well informed about these safety protocols and the nature of the risks associated with Yellowstone's volcanic features is vital. This approach helps in minimizing unnecessary panic. It also ensures that individuals react thoughtfully and safely in the face of potential volcanic activity. Despite all these precautions, there is no one way of predicting the exact timing of when the Yellowstone volcano will erupt. With the massive dome rising in size and the panic it has caused in scientists all over the world, it remains to be seen what will happen in the future in Yellowstone. Outro. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable.